Meteorologists predict that in the town of Moose Jaw on June 18th, it will be raining with a 40% chance. And we'll see wind with a 35% chance, and you'll have both rain and wind in Moose Jaw, 10% chance for that on that day, June 18th. What is the probability that Moose Jaw will be raining but not windy on that day? Okay. So we've got some meteorological events worth mentioning. We might say something like let R equal the event it rains in Moose Jaw, and maybe W, the event that it's windy. We can take the information presented as percentages and turn them into probabilities here. So we could say, for example, the probability of rain is, well, 40 is too big to be a probability, but you measure it out of 100. You get 40 out of 100, you could say 0.4. Okay? Or you could leave it as something like 2/5 or 4/10 if you prefer fractions. Okay? Similarly, what's the probability that it's going to be windy? 35% out of 100%. The nice thing about percents is just take the number you had, 35, move the decimal place over twice. So we'll get 0.35 is the probability that it will be windy on the 18th of June in Moose Jaw. Okay? And then, probability that is both raining and windy, which is represented with an intersection of these events, right? Both and, these are exactly the terms we see in English to represent an intersection of sets, or in this case specifically intersection of events. And we're told that's a 10% chance, that's 0.1. Okay. And now what do we want? We want the probability that Moose Jaw will see rain, okay, not wind. Okay, so rain, but not wind. So yes on rain. What about wind? No on wind. So rain, yes, and no for the wind. So what is that probability here? Okay. Well, we have enough information to figure it out. In fact, we don't even need to know the probability of wind to answer this. Okay? We can use a nice little formula. So normally the formula would be probably written like this. Probability of any event can be broken down into the probability that that event and other event, we'll call it F, happen, plus the probability that E happens but F doesn't happen. Okay? Specifically for us, we don't have events E and F, like you might if you're just blindly listing out a formula. We've got R and W. But if we come along and play the replacement game, the probability of R, that it rains, can be broken down into the chance of it raining and windy, and that it's windy in Moose Jaw, plus the probability that it's going to rain, but there's no wind. Well, we know this is 0.4. They gave us that in the question. We know the intersection has a probability of 0.1. And then, well, the other one's the one we're missing. So what do you have to add to 0.1 to get to 0.3? To get to 0.4? 0.3. So 0.3, or you could say it's a 30% chance that Moose Jaw will see rain on June 18th, but not wind. All right, well, there we go. There's our final answer. All we needed was to sort of decode and then apply one of the formulas that we know.